So I guess I also wanted to thank Peter Lovely, because it has been also great to have interactions with Chevron and have very stimulating discussions about the evolution of the Northwest Shelf and I mean other topics around the world. So thank you, Peter. That was a very nice way to, I guess, start this talk on that such a positive note. Yeah, so I guess, yeah, Chris and I are going to two people show. And the research that we are going to be presenting incorporates multiple sources of data, including seismic, zircon geochronology, thermochronology, and numerical modeling. And it was made possible by a large team of honors, PhD students, and postdocs, who were supervised by the BGHCIs. So I know that I've gone through this slide a couple of times, but I guess just to make sure that people who have missed other sessions understand the background of the Northwest Shelf, I'm just going to go through this slide really quickly. So yeah, the Northwest Shelf is a prime example of a polyrift margin where we have several seen rift events in the Paleozoic and in the Mesozoic, and subsequent post-rift phases in the Triassic and in the Cenozoic. And these different rifting events are related to supercontinental breakup, as you can see in the tectonic reconstructions that I'm showing you here. And these events also control the style of clastic and carbonate sedimentation. So for example, in relation to clastic sedimentation, we have deltas of contrastic styles in the Triassic and then the lower Cretaceous. So then after the upper Cretaceous, the Northwest Shelf became a passive margin, as you can see here. And it has experienced an increased subsidence after 50 MA, which is probably related to the fact that Australia is now at the leading edge of the plate and moving towards Southeast Asia. And what is interesting is that movement of Australia towards the north has also resulted in the aridification of Australia and has changed ocean circulation patterns, which subsequently have controlled rift formation and also the size of and the decrease of clastic discharge to the shell. So yeah, I'm starting in the Paleozoic to the Triassic. The first phase of rifting starts in the Ordovician with the opening of the Canning, Petrel, and Perth basins, as you can see on the map to the right. And based on thermochronology data, we determined that far-field stresses caused lithospheric stretching and changes in base level, which in turn resulted in the denudation of the sedimentary cover in the Pilbara Craton. And that the results of that study can be were published last year in Tectonics. And what is also interesting is that we were able to, I guess, place the opening of the Canning Basin in a continental scale framework by understanding the far-field stresses. We also have this seismic line. I guess a lot of the work that Chris has been doing, it relates to, I guess, the interpretation of seismic lines. And as you can see, so several wells have penetrated the Devonian and early Carboniferous sediments in the southern part of the Petrel Basin. And this section shows that they are strongly faulted, and the displacements, as you can see here, by extensional faults have large throws of up to 1 kilometer. And the fault blocks are eroded and overlain by Carboniferous sediments, suggesting that that extension was short-lived. And as you can see, there is also salt diapirs and salt bodies, which based on stratigraphic relationship suggests that they are Devonian in age. Then in the Carboniferous Permian, we have the localization of the rifting in the Fitzroy Trough, as you can see here, and in the Petrel Basin in the early Carboniferous. And then the localization of the deformation here in the Fitzroy Trough also allows the position of up to 3 kilometers of sediments. And that's, as you can see here, shown in this thickness map. We also have widespread rifting on the northeast, northwest trending basins in the Northwest Shelf, and the development of marginal faults. And that work, like all the mapping of these marginal faults, was done by Amy and was published in Marine and Petroleum Geology. I guess just to illustrate that, you can see, for example, the seismic line that I'm showing here. That's the location of the seismic line. And that seismic line shows the rotated upper Carboniferous and Permian sediments below the clear angular unconformity with Triassic sediments. So as you can see here, this is the, I guess, the unconformity, and then you have the Triassic sediments. So then in the Triassic, we have continued rifting in the Browse and the Bonaparte. And I guess that's one of the interesting things about the Northwest Shelf, that we have this diachronicity in the rifting of the margin. So while we have a passive, or like, while the rifting stops here in this part of the basin, then we have the rifting on the Browse and the Bonaparte. And then so that post-rift subsidence in the Northern Canal and in the Roebuck basins allows the deposition of these fluvio-deltaic sequences with delivered via large-scale drainage systems with headwaters in Antarctica, Southwest and Central Australia. And also we have volcanic sources. Chris has been working on these magnificent, or like these great maps through time using extensive seismic data. And so as you can see, this is a map of the base of the Triassic, and it shows the structure. So the Permian marginal fault system is very clear, and it clearly marks the edge of this Triassic depot center. And then, as you can see, the sediment filling in this depot center is relatively uniform in thickness. So the shape of the Triassic, again, depot center is shown. As you can see, there is a clear difference here in the edge of the depot center. And then, I guess what is interesting is that based on the work of John Martin, you can see that all these paleo channels and these channel belts have been mapped, which clearly show the size and extent of this system. And then I guess, so then there is the same and provenance work that we also carried out, which I guess Peter talked about. But so one of the interesting things is that we also teamed up with Geoscience Australia, and we were able to get these large databases of zircon chronology, and also do subsequent hafnium analysis in some of those zircons. So thank you to GA as well for allowing us to carry out subsequent analysis on those zircons. So as you can see, based on these zircon populations, we were able to determine the provenance of this system with sources from Antarctica, Southwest Australia, and Central Australia. And then the other thing that was really interesting was that we were able to place these data in tectonic framework by using G-plates. So that was also a very powerful combination to make sure that the geochronology data and the tectonic framework were in accordance. We also were able to discover this large population of zircons in the Triassic. And then what is really interesting is that, so that matches the like previous dating of rhyolites and or volcanic sequences in places like the Wombat Plateau. And we were also able to, I guess, to use other scaling relationships to get our lines of evidence to support that this was indeed continental scale catchment. And we did that by, I guess, if you wish to call it that way, but to do like an inversion of using channel bed thicknesses, and then I guess using relationships to back calculate what was the size of the drainage area. And then what is also interesting is that that matched the also, like if we also measured the length of that river system and then bulk calculate the drainage area. So then you can see that I guess that both lines of evidence give the same result. So I guess one of the interesting things about the Triassic or questions is about what caused such a large subsidence in a post-rift setting. And so I guess Chris has some ideas about that, but it might be that it's a combination between the fail arm of that rift system allows to create the subsidence, but we also have the flexural subsidence of such a thick sedimentary sequence. And I guess to focus on that, I created a series of simulations in badlands, and I understand that there are conceptual models, and they might have some limitations, but at least those series of simulations allow us to understand what is the role of that flexural subsidence in continental scale deltas. And that work can be found in the atlas as well. So then at the end of the Triassic, we have changing the geodynamics in the region, and that triggers lithospheric extension in the Northwest Shelf. So that triggers the rifting of Argoland. And that work was published by Sabine Zahirovic in 2014. And I guess, so this is the end of my segment, and I'll let Chris carry on.